What's up everyone, welcome to part 3 of our pose estimation tutorial series, and in this one we're going to continue with 3D pose estimation. So in the previous video we looked at how to do 3D pose estimation on an image, and we also took some old code that's using PyQt-Graph and OpenGL to do 3D graphics. Well, in this one we're going to combine those two together to make real-time 3D pose estimation. So we've got a lot to cover, so let's get into it. Let's begin by doing a quick recap of the previous video. So in that one, we'd started with some old code from our audio spectrum analyzer series, and we're using the code that was the audio reactive mesh. So it was this mesh, and its height would vary based on input from our microphone. And what we'd done is remove all the audio stuff, and we just left the mesh. So the important thing was the mesh was animated, and it was just varying with some random number. But we had some object that was being animated. So that's the starting point. Now what we're going to do is, instead of a mesh, we're just going to plot points and lines, and those lines are going to be our key points for our body. So now I just want to give a quick overview of what the class was doing and how we're going to modify the class. So in our class we've got 5 methods. Like always, we have init, then we have mesh, update, start, and animation. So in it, we're just going to be creating the window and initializing all those plot and graph objects. Mesh, what we're going to be doing is all our 3D plot or 3D pose estimation code is going to go in mesh. It's basically just going to return all the key points. Then once we have that, we're going to use the update method to take those key points and update all our plot objects. So this is going to be taking the key points and updating all our plot objects. Next we've got start, and start we're not even going to touch. This one's just going to be left as is. And same with animation, we're not even going to touch it. It's good the way it is. So now that we have somewhat of a plan of attack, let's start working on the code itself. So let's start by adding the imports we're going to need. So I'm just going to copy and paste these, but we're going to need CV2, time, and OS. And then from our GitHub code, we're going to need from estimator, we're going to use tfpose estimator. From networks, we're going to import get graph path and model WH. And then from lifting.prob model, we're going to import prob 3D pose. And then we're also going to import common. So now that we've got that, let's start by working on the init method. So the first thing I want to do is I want to add some grids in the 3 planes, in the XY, YZ, and ZX plane. So these are just going to be grids that are just filling up the background. So again, I'm just going to copy and paste those, but right below the self.window.show, we're going to place it here. So we're going to create 3 grid items, and we're going to call them GX, GY, GZ. Then we're going to rotate 2 of them, GX and GY. And then we're going to translate all of them so they're pushed out to the background. And then finally, we're just going to add them all to the window. So just to show you what it looks like, I'm just going to go ahead and run this. All right, so you can see the grids in the background. I'm not sure if you can see the one on the bottom, but we've got some sort of grids in the background. All right. Now to see what we need to do to add to our init method, I'm going to open up the run.py file. So I'm just going to move it into a side window so we can take a look at it. But if we come down here, I'm just going to move this over so we can see a little better. But all these argparse things we can kind of ignore, but we need a model, and that's pretty much it. So what we're going to do is call model WH, and we're going to pass the model so we can get this width and height. Then we're going to get the graph. So we're also going to pass our model here with our target WH values. So then we can get E. And then E, we're going to use that to do inference. So we'll be able to take an image. You can see pass an image, get humans back. And humans is a list of all the humans that we're going to estimate their pose with. So just to get this thing going, I'm going to move this back over And I'm going to come up here to the top. So we aren't going to need a lot of this stuff here, but I'm just going to leave it for now. So what I'm going to do is create our model. And our model, remember, it was just that MobileNet thin 432 by 368. All right, then the next thing we're going to do is we're just going to use that WH, and it's going to be model underscore WH, and we're going to pass in the model. Next thing we're going to do is we're going to create that E object, but instead we're going to call it self.E. That way we can use it in other methods in our class, but it's going to be TF capital pose, so TF pose estimator, and then we're going to pass the get graph path, and we're going to pass in the model, and also the target size is going to be, it's going to be W by H. Oops. So just so you can see here, we're basically just doing the same thing. Instead of args.model, we just created our own object for model. All right, so now that we've got our self.E object, we're going to need to do inference on our object, but instead of an image, we're going to be using images from our camera. So the way that's going to work, I'm just going to move this over, give us more room. So I'm going to create another constant, and it's going to be called camera, and this is going to be 0. And then we're going to create another object called self.cam, and that's going to be equal to cv2.video capture. And what we're going to capture from is our camera. All right, so now remember we want to read from our camera to get the image. So we're going to do ret val comma image, and that's going to be equal to self.cam, and what we're going to do is read from the cam. So when we read it, it's going to return an image, and ret.val is basically true if the camera is on and collecting images, and it's false if the camera's off. So cool. So now once we've done that, we also need to, if we scroll down to the 3D part, you'll see that there's this thing called Prob 3D pose. So here we're loading this this mat file, and we're going to use this to do the 3D pose estimation. So I'm also going to copy this stuff here. So I'm just going to copy this whole thing. Come back over here, and right below here, I'm just going to paste it there. And instead of pose lifting, I'm going to call it self.pose lifting. So now we'll have this object to do our 3D pose inference later. Next, what I want to do is I want to take this image and I want to do the inference on it. So all that inference and 3D pose estimation, I'm going to move it to the mesh method. So remember this method here, this is going to do all the inference stuff. So basically I want mesh to just return all the key points. So the way we're going to do that is I'm going to come right here below our self.pose lifting, and I'm going to say key points is going to be equal to self.mesh, and all I want to do is pass the image and I want to get the key points back. So we're going to need to do some work on mesh, but for now this is the functionality that I want. So I'm going to leave that, and then once I've got those key points, what I want to do is create a GL Scatterplot object. So I'm going to create this thing called self.points, and this is going to be equal to gl.g capital GL scatter plot item. Yeah, that's it. And then I'm just going to come down here, and the POS is going to be the key points. Then the color is just going to be for now pg.color, and I'm just going to do green for now. So 0, 255, and 0. Then next, we're going to make the size of these things equal to 15. So what this GL Scatterplot item is, it's just going to be dots. So we're just going to take our key points and plot dots with it. And they're going to be green dots and they're going to be size 15. Cool. So now what I want to do, once I've created this self.points, I'm going to add them to our window. So the way we do that is self.window.addItem, and then we're going to add our points, our self.points. So now that we've done that, I'm just going to erase all this other leftover code that created the mesh and everything. So we can just delete that. And now what I want to do is work on our mesh method. So I'm going to come to our mesh method, just scroll down, and instead of height, we're going to pass in the image, because remember, we want to pass in an image and we want it to return our key points. So I'm just going to delete all of this for now, because we're not going to use any of it. And instead of all this stuff, we're just going to return key points. All right, so now to see how this is going to work, again, we're going to refer to the run.py file. So if I scroll back up to the top, we've loaded our model. Basically, we're going to take this E, in our case, it's self.e, and we're going to do e.inference on our image. So why don't I just copy this line? And it's going to be self.e. We're going to take in our image, and we're going to get our humans out of it. So that, actually, no, we don't need to do self, because we're not going to be using it outside of the mesh method. So also, once we have that, we're going to need a few more things. So I'm just going to copy and paste these constants from it, but from our image, we're going to get the shape. So we're going to define image height and image width, and we're also going to define these constants, width and height, 640 and 480. Then we're going to create two lists, the pose 2D MPIIS and the visibilities. So these are just two empty lists. Then we're going to do inference on our image so we can get the humans from it. So now that we've done that, basically what we're going to do is we're going to loop over our humans. So if we come down here, you can see we've just taken all this stuff right from run.py, and we're going to loop over the humans, and we're going to call all this stuff. So we're going to pass the human, and from common, we're going to do this from Cocoa part to create these two things. And then we're going to be appending this stuff to our list. So these are the two lists that we created, and you can see we're appending some stuff from it. And this is basically all the key points. So we're taking these key points and adding them to our list. And then once we've done that, we're going to take our list, we're going to convert them to NumPy arrays, and then we're going to do some 3D stuff on it. So we're going to pass those lists into this pose.lifting transform joints to get these new things. And finally, we're going to call pose.lifting compute 3D, and we're going to take these things that we returned, pass them in here, and finally get our pose 3D points. So if you remember in the previous video, we printed these out, and these pose 3D, these are the key points. These are the X, Y, and Z coordinates for our 3D key points. So basically we just need to take all this code and return these, but we're going to format it slightly to make it nicer for PyQt graph. So we're just going to do this transpose operation. So I'm going to copy a lot of this stuff over. So we'll again go through it one more time, but just so we can see. So just going to shrink this over so we can see it a little better. So again, we're doing a for loop over humans. So for human and humans, we're going to call this common MPII part from Cocoa. We're going to pass in human, and we're going to get these returned parts from it. And then basically we're going to loop over this thing. So we're going to loop over it, and we're going to get all our 2D key points from it. Then So we're going to append it to this list. Then we're going to take this visibility, append it to our visibilities list. Then we're going to create NumPy arrays for these parts and for the visibilities as well. And let me just get rid of that. That's just for timing. And then we're going to take those NumPy arrays. We're going to do pose lifting self dot transform joints. And we're going to get these transformed pose 2D and weights. And then we pass them into the compute 3D and we get our 3D points. So to give like a summary of it, we get our humans, we get our 2D points, and then we get our 3D points. So that's what's going on here. So finally, what I'm going to do is call key points. And what key points is going to be is we're just going to take these pose 3D points and we're going to take the first part of it and then we're going to call transpose. Yeah, we're just going to call transpose on it. And that way it puts it into the correct format for PyQt graph. And then we're just going to return it and we're done. Now that we're done with our mesh method, the next method I want to work on is updates. So remember, if we come up to the init method, we created this self.points, and points was this GL Scatterplot item. So now in update, what we're going to do is update self.points. So update is going to call mesh, get the new key points, and then update self.points, and then display it. So let's come down to update, and we're going to delete this stuff. So the first thing we're going to do is we need to read from our camera again. So we're just going to use the same line of code. It's going to be ret_val, comma image is going to be self.cam.read. Now we got our image. So what I'm going to do is I'm going to put it in a try statement because sometimes it can return errors, but we're going to try and get the key points. So remember, we're going to call self.mesh and we're just going to pass in the image. So we're going to try and get the key points, and the only thing is except if we get an assertion error. Basically, if we get an assertion error, it means it couldn't find any humans, so that the humans list is empty. So we're just going to print body not in image. Now that we've taken care of that, so now we're going to call else. So what else means in a try except statement, it means if you didn't get the error, run this code. So if we don't get the error, what we're going to do is self.points, we're going to set data. So now we're going to update self.points, and the data that we're going to use, we're going to just update the POS, and that's going to be the key points. And that's it. So yeah, that's all we need for updating. So now let's just double check the animation. I'm just going to check this one to see if I changed anything. So no, I didn't. So now, fingers crossed, we should, when we run this, we should get just some key points, like some dots displaying in 3D. So, and actually one more thing, since the coordinates of our points, they're going to be kind of large, so they're going to extend outside the frame. So I'm just going to divide this by 80 just so the key points show up in the screen. So now, fingers crossed, I'm going to go ahead and run this. And one more thing I forgot, before we run, we need to move up one directory. So right now we're in the src directory, and we need to be in the top level of that directory. So in order to move up one, we're just going to call os.changedir, and to move up one is just ... So now I'm going to run it and it should work. Fingers crossed. Okay, all right, we've missed something. So instead of calling self.e, we called e. So I'm just gonna scroll up. It was right, where is it? Right here. Self.e. Let's try one more time. Oh, and okay, we forgot one more thing. Sorry about that. So PG, what did we call it? Oh, okay, we forgot to import pyqt graph as PG. All right, now it should work. Sorry about that, guys. All right, so we've got the graph. Where are the points? Hold on one sec. Let's exit out of it. So body not an image. Oh, FN not defined. So where is FN? Okay, I'm just gonna pause this real quick while I figure out what's wrong. All right, we're back. So I called PG color instead of pg.gl color. So now it should work. Enough tries, so fingers crossed. Let's hope this works. All right, we've got the points. So yeah, so now we've got the points. They're updating. You can see it's not super fast because the 3D pose estimation is a little bit more CPU/GPU intensive, but we've got it working. You can see the basic outline of me. So yeah, we've got our basic structure. So the next part is going to be to add the lines, which isn't too much, but I'm going to save it for the next video just to keep this video from going too long. So that's going to be it for this video. If you guys liked it, leave a like below. If you've got any problems or questions, leave a comment below, or you can use the Facebook group to chat more about it. But yeah, I hope you guys like the content, and if you really do, then hit the subscribe button. So thanks again for everything, guys, and I'll see you in the next one. Peace.